Okay, let's talk a little bit about importing and exporting data into R. So basic commands to read in a file, you have things like read.csv, which I think many of you are familiar with. But related to that, you have read.table and readline. Sometimes read.csv will bring in strings as factors. I think the default is set strings as factors equals false, but it's I like to still kind of input that for good measure there. There's a bunch of other packages, and instead of using read.csv, which works fine in base R, I prefer using readr, which is part of the tidyverse. And so you can read about readr in the tidyverse, and that brings in read_csv, and it's generally faster and more efficient. There's a few other packages. So if you want to bring in Excel files, you can load the library read Excel. And then there's also Haven, which allows you to import files from, say, Stata, SPSS, or SAS if you're using a different statistical software program. There's another package called data.table, and that is designed to work very quickly, and it handles really large files pretty well. So if you are dealing with a really large file on the order of hundreds of thousands or millions of rows, I would say data.table is the way to go. If you load up readr, then probably the most common function you'll use is read_csv, which will load up comma-separated files, which is probably the most common form. It's a text file, and it just kind of has the data right there in text format. But then you have other kind of things that are able to read it in. So you have tab-separated files, delimited files, fixed-width files, and you can read the help files for each of these different functions. Just a little bit about data.table. It's designed for the fastest performance. And again, if you have a massive data file, load up data.table and use fread, fast reader, okay, which operates very similar to read_csv, but will be fast. And I'll just kind of skip over this slide, but basically it says, it's a comparison of read_csv from reader and fread from data table. There's a little bit of text there. Okay, if you're going to use an Excel file, you'll load up read Excel, and you can just load in the first worksheet by whatever your Excel file is, datasets.xls or whatever it is. If you have other, multiple worksheets in your Excel file, because Excel supports that, you can specify the sheet by name or the sheet by number, and that will work there. Sometimes you want to load data or whatever that's found online, and this is especially useful if you want to give your script to a colleague or a classmate, and rather than having to also give the script and the data file, that data might be uploaded somewhere on GitHub or some public place where you can get you can download the thing. And so rather than having to say, all right, please go to this website and then download the thing and put it into your working directory, you can just include those instructions for downloading the data in your R script. And then so when they run the R script, it will download the data and load it up for them. So so there is a native download.file function. However, this is an old function from dating back to the early days of the internet, where things were much less secure. Now, almost every website uses HTTPS as their protocol, their secure protocol. So, and download.file just doesn't run very well with that. So there's a package called Downloader. You might need to install it, but you just load it up, library downloader, and then you run the function download. So here there is a URL. You can see it's a secure URL, HTTPS, and it's just from GitHub, and GitHub kind of posts some of their stuff. So here I uploaded the iris.csv dataset to GitHub, and the address of the CSV file directly is right here. And then I can call download, put in the URL. Where do I want to download it to? I'll specify that file name. File is iris.csv. And so this is going to get saved to my working directory. And now that the file is saved to my working directory, I can then call read_csv to load it up and store that into Iris. So, so this is a handy little way of basically putting into your script instructions for downloading the file. If you want to export your objects so that you can load them up in another program, or use them later or something like that, there's a few ways you can do this. One is you can store them into just a .r data file, and so this will work if you're going to load up the data and the packages, or data and the objects, back into R. So you just say, these are the objects I want, and then you click file equals whatever, you specify where you want to store them, and you click save. Okay. If you want to save some like an atomic vector as plain text, you can also specify that using write. So you can do write, and then you put in the object name, some kind of like the atomic vector. You put in the name of the file, number of columns, and it will just create a column of values for you. Right? If you have a data frame and you want to store it as a CSV file, then you can do write.csv. Write.csv, you specify the name of your data frame, and then you say, I want to store it to, dataframe.csv, or whatever it is. The default behavior is that it includes row names, and I don't like that. So I recommend including the option row.names equals false. Okay. All right, and so that's how you would export data. I want to draw special attention to a package called Lubridate, which allows you to work with date information. So a lot of times when you download a CSV file from out in the wild and you want to bring it into R, it might have date information, and dealing with date information in R can be super tedious and annoying. But Lubridate really kind of cleans this up. And as far as I know, we don't have a similar package to Lubridate in Python. And so this is like one of these packages that really is amazing to work with in R. As far as I know, with Python, you still have to kind of go through this annoying formatting system. So the annoying formatting system looks like this. You have to use like this %b, %d, %y, and it's very, very, very picky. Because if you mess one of these things up, so here the date is coming in as a string, January 15, 1999. If you mess that up and you don't include the comma, it doesn't understand. Okay. Here there's dashes, December 15th, 2001. If you leave out the dashes, it crashes. It doesn't work. So it's annoying. Okay. And this, again, if you have a mix of formats, it just doesn't work. With Lubridate, you can have a mix of formats, and all you have to do is you say, hey, these are stored in month, day, year, and poof, it understands all of it, right? Whether it's January 15th, 1999 spelled out that way, 12-15-2001, or 03/18/2002, all of these things work out, okay? So Lubridate is super great, super awesome. Okay, it does require you to specify the order of the fields. So if you have 03, 04, or 5, that's a bit ambiguous because that could be year, month, day. 2003, April 5th. It could be month, day, year. That would be March 4th, 2005. It could be day, month, year. Okay, the April 3rd, 2005, or something like that. Okay. If you try to say like month, day, year, and you give it something like the 25th month, then that's not going to work. Okay, then it will return an NA if you can't parse it. But anyway, that's Lubridate. I highly recommend it if you think you're going to have to deal with date information.